Hello, let's continue our Sudoku adventure with Cygnus by Riffclown. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have black crop key. So we have black dots in the grid that touch 2 digits. The 2 digits it touches have to have a 1 to 2 ratio, meaning that one is exactly double the other. So if this was a 2, then this could be a 1 because 2 is double 1, or it could be a 4 because 4 is double 2. Now, all possible dots are given, meaning all possible black dots are given, right? Meaning if I were to put, if the solution had 2, 4 here, then there would be a black dot, which means the solution is not 2, 4. So if there's a 2 here, I can't put a 4 next to it. I also can't put a 1 next to it because there could be a black dot, and so there should be. So that is a restriction on every cell. Usually we're used to black dots only affecting the 2 cells it touches. In this case, we do have what's called a negative constraint, which prevents hidden black dots, basically. There should have been a black dot there, so I can't do that. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. I'm seeing our givens here, and like this given 1 here, it removes 2, right? You can't put a 2 next to it or there should be a black dot. And so that means 2 in this box definitely ends up in one of these 2 cells. And now 2 would be down here, but it can't be next to the 1. So 2 is in one of these 2. 5 is kind of a free spirit. It doesn't prevent anything because you can't have it to 2.5. You can't double it to 10. So basically 5s don't go on black dots. And so they're definitely going to go next to anything else. They can go next to anything else, I guess is the way to put that. 3, though, can't be next to 6. So none of these are 6. And in fact, if we look at these black dots, there are exactly 3 ways to fulfill them. You can do 1, 2. You can do 2, 4. Or you can do 3, 6. And if you think about it, that means that the lower digit, the one that gets doubled, is going to be 1, 2, or 3. And then we're going to double it to 2, 4, or 6. So we always have one cell being 1, 2, 3, and the other 2, 4, 6 in some order. The other order could be swapped. But because these don't have 3 on them, they also don't have 6 on them. And we just said that 5 isn't possible. So we're either going to be doing 1, 2, or we're going to be doing 2, 4, meaning they definitely have 2s on them. But remember, this can't be a 2 because it's next to a 1, and it also can't be 1. So this must be 4, which makes that 2. And then over here, we know there's a 2 on it. The 3 can't be next to 6. That's fine. All right, so we got some 2s here. So the remaining digits here are 3, 5, 6. Now, the one thing I do know is that this can't be a 3, 6 pair, right? Because there would have to be a black dot, meaning this is one of the 3 6s, which means this is 3, 5, 6. That's not a 3, and the 5's up here, meaning the 5 is one of these 2. All right. The rest of this column is 1, 5, 6, and this can't be a 6 because of the 3, and it can't be a 5. So it is a 1. Leaving 5, 6 behind. Okay, so this black dot doesn't have a 1 on it. So it's 2, 4, or 3, 6. If it was 2, 4, this can't be the 2 because it would be next to a 1. So that's 2, 4, and then 3, 6 seems to be possible either way, as far as I can tell. 2 can't be next to the 4 here. This can't be 6. What else? What have I not looked at? This can't be a 2. I have a 2 corner mark there, but I just placed that 4. So that's not a 2. That places the 2 in this box, which places the 2 here, leaving the 1, 4 over here. Okay. 6 is here or here. What do I do with all that? We know there's a 1 in one of these 2. This box, there's a 1 in one of these 2. Okay, we have 2 2s looking down. 2's in one of these 2. Is there anything else I can do? Okay, so this box needs 1, 4, 5, 6. So these are from 4, 5, 6. This can't be the 4. It would be next to a 2. This can't be a 6. It would be next to a 3. I'm thinking about if this is The two options are 2, 4, or 3, 6. I'm seeing if either of those fail for some reason. Well, where's the 2 in the column? That's the key thing. These 2's look down. 2 can't be next to the 1. That's what I was missing. So this is the 2, and that makes this the 4. We get the 5, 6, and 3, and that's 5 and 6. We get the 6 here and the 2 up here. All right. Rest of this row is the 3, 6 pair that we're missing. The 6 tells us the order. That's 3, that's 6. So over here, this is the 5, and then over here we need 1, 3, and 4. It's not the 1. This isn't the 3 because it's next to a 6. This isn't the 4, it's next to a 2. So that's 3. All right, 3 in the corner celebrating. Being a 3. We need 4, 5, 6 here. So this can't be the 4 or 6. So that's our 5. That places the 4 and the 6, and the 1 and the 4 and the 1. We get the 1 here. This digit is the 4. These two digits are 3, 5. We know the order. This digit is a 3. And then up here we need the 6 and the 4, and we're done. Okay, cool. Nice puzzle, Riffclown. I liked the use of the negative constraint there. We got to show a bunch of negative constraint tricks, which was neat. All right, well, let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.